Bismillahirrahmanirrahim. Welcome back to my channel Think Big Learn Smart, and today we are going to talk about the 8051 assembly language programming. Before moving on, we have to know what is an 8051. 8051, please bear with my writing. 8051 is a microcontroller, and we are going to understand about this programming, but this lecture is going to be an introduction about the 8051 microcontroller. In the next lectures, in the upcoming lectures, I am going to talk about the assembly language. So before moving on, we have to understand what is basically an assembly language. Assembly language is a low level language that is used for programming the hardware, machine, or the electronic devices. As we know that a machine understands the language of ones and zeros, which in terms of technical jargon it is also known as a binary language. But for humans it is very difficult for us to understand this language, because for a human eye it is very difficult to know the patterns in this language and to program it usefully for our hardware use. So what we do is that we use the assembly language, which is basically a symbolic representation of machine language, and it makes us a little bit easier for us to program the hardware. But it is known as a low level language because it is difficult for normal person to understand, while as the technology have progressed, there are more languages that are being generated and they are more user friendly, or I would say that they are more programmer friendly, and they are known as high level languages. They are easy to understand for the programmers. They contain a lot of English words that help the programmers to develop a certain program for a certain task. But then the question arises that then what is the relevance of assembly language is in this technological era, when we have progressed towards high level languages where the level of difficulty is quite low. And then what is the purpose of assembly language? Assembly language, there is a purpose for that, and we will understand by this simple example. For example, if I write an instruction in the language of Python, it is that output inverted commas hello world. This is a simple instruction. As you can understand that if this instruction is processed, that the programmer will know that it have to output this string on any output device, where it will be written simply hello world. But how it is being processed? First of all, this instruction will go into the compiler, where the compiler will change it into a bit understandable for the machine. Then this compiler will move on it towards the assembler. Then assembler will change it into a language which a machine understands, and the task is being done according to that instruction. So what the assembly language does is that it bypasses that compiler part, and the assembly language is directly goes to assembler and being processed. So from that you can know that the compiler is being skipped, and that saves a lot of time. And as we know, in electronics, time is a treasure. Even the delay of micro and milliseconds can cause a lot of harm. So this is the use of assembly language. It saves a lot of time, and it also saves the space as well. It is very fast to execute, so there are few benefits for that, and I'm going to write there that it is fast, takes less memory, then another benefit that we can get from that assembly language is that it helps a programmer to get a good grasp of hardware, how instructions are processed, So these are the few benefits of the use of assembly language. Now I hope you will understand that why an assembly language is used. So let's move on towards this term that I talked about earlier. It is microcontroller. What is microcontroller? Most commonly, microcontroller and microprocessor are used interchangeably, but these two are distinct things, and we will understand in our next slide. So let's move on. So microcontroller is basically a device that contains CPU and other peripheral devices like RAM, ROM, and yeah, that's what is an analog to digital converter, and it also contains a microprocessor. So that is a microcontroller. Microcontroller contains in a single chip all these peripheral devices and plus microprocessor, while microprocessor is a single silicon chip, integrated chip, and it doesn't contain a RAM, ROM, or IO limits and all these kind of things, and it is basically a simple device used for a brain. Used as a brain of microcontroller. Microcontroller is used for specific purposes, for specific applications. It is simple and simple to use, while microprocessor is quite complex and expensive, and it can be used for general purposes because it can process a lot of data. It can be used for general purpose as it can process a lot of data. So that's another use of microcontroller, microprocessor. That's a simple difference between microprocessor and microcontroller. So that was all, and let's move on to the physical outlook of 8051 microcontroller. 8051 microcontroller looks like this physically, as you can see it here. As you can see it here, it contains 4 ports: port 1, port 0, port 2, and port 3. Every port contains 8 pins, and these 3 ports, these all 4 ports can be used as an input and output pins, and the other pins are its VCC, reset pin, and ground, 2 crystal pins plus ALE and preset pins. These are used for connecting external devices, and in a block diagram this can be said that these are connected like that. There are 2 timers in 8051. There is a RAM of 128 bytes in 8051, 4 kilobytes of ROM in it. 4 kilobytes mean 4096 locations for storing the program or instructions. And there is an interrupt control, a CPU, and there are 2 oscillators that connect to it, and there is a bus control system. So that's the basic structure of an 8051. Now let's move on towards the RAM space allocation of 8051. It is very necessary for us to understand the RAM space allocation of 8051, as in the programs that we will discuss in the future, we will understand the usefulness of this understanding about the RAM, because all the instructions are being processed in the RAM, and it will, if we know about the RAM space allocation, it will be very easy for us to understand the program and to develop it by ourselves. So the RAM of 8051 contains 4 register banks. This 4 register banks. Every register bank contains 8 byte of registers. All right, 8 registers. Every register have got 1 byte. Like if I talk about this R0 register, it contains 1 byte, which also means 8 bits, and from that I will tell you that 8051 is an 8-bit microcontroller. It deals in 8 bits of data at a particular time. So these 32 bytes are our register banks, dedicated to our register banks. Then there are 16 bytes that are dedicated for the bit addressable RAM. That can be that means that it's in these register can be used for bit addressing. Every bit can be used in a program for a particular purpose. The 16 bytes are bit addressable. Then there is an 80 byte of RAM that is allocated for general purpose, also known as a scratch pad, which is used for storing data and for storing the parameters and all these kind of things. And here is the specifications of 8051 microcontroller. It contains 4 kilobytes of ROM and 128 bytes of RAM, 32 pins of IO pins, as I said earlier, 2 timers, 6 interrupts, 5 volt and 40 pins physically. So that was the RAM space allocation of 8051 microcontroller. And so what's next? What we are going to talk about in our next lecture? In the next lecture, I will directly start with the instruction set of assembly language, and I will explain them with the examples so that you can understand it easily and you can program it by yourself. So that is the part of that will be the part of our new lecture. So that was all. Thank you very much for your time. Please like, comment and share and subscribe. Thank you very much. Allah Hafiz.